All right, welcome everybody. This is going to be the very first stream. So I am a noob here. Bear with me if you hear something weird. Sorry. I'm going to open the chat onto the right screen that I have so that I know what's happening. And if there is an audio that I'm hearing, I should fix that as well. I don't think I'm listening. Yes, that's muted. Okay, so where do we start? Um, I think this the intent here is to have a beginner series. Being myself a beginner, we will be starting from scratch, as in where you can get Rust, and at the same time we will not be going through like this is the data types that Rust supports. This is what you can do with Rust. No, we'll be diving right straight away into building something as in trying to do some things, and then maybe at this while we go through it we will learn how Rust works, and we will actually do it more or less like burn our hands straight away. So let's get started. The only thing that came in mind when I was trying to think about ways how to go by this was advent of Rust. I learned about this I think last week, and I was quite interested. Maybe I should try it out, but never really continued. So let's get started with the advent of Rust. So wait, let me switch my screen view if I can at some point. Okay, so you should still be able to see me down here onto your left corner, I think. Okay. So you should be seeing a Chrome window, and on your screen, if you search Advent of Rust, you will see Rust Infinity, and they have this Advent of Rust 2024 going on. So let's start from there. Now, I will not get you into how to install Rust. I think you are more than enough capable of doing that by yourself. And plus, we are not installing anything onto a local system. We will be doing everything in their environment. It's more or less like you would solve problems on lead code. So let's start from there. And if you feel interested in Rust, then you can gradually adapt to installing Rust on your system and then start playing. Let's start solving problems. I did register, I think, last week only, and I also, I think, solved one or two problems. I'm not really sure. I don't exactly remember. There is some progress. I did complete a few. Okay, it says I solved three. Okay, let's start from day one again. So this looks scary at the beginning. Let's break it down bit by bit. So, as any programming language, Rust also has a function main. This serves as the entry point for your language that I think everyone should be very familiar with. I'm a beginner myself, so bear with me if I'm not explaining things in very detail because I'm still learning. The way you can define variables is using let keyword, and as you can also notice that we have to use semicolons in Rust. Case. So main is our entry point. Let and then the word, the variable name allows you to create variables in Rust. String from is you can as of now you can ignore this part. Basically, what it's doing is it's trying to create a string. String is a little more complicated in Rust, as far as I've learned so far, based on my little experience that I've had trying to get into Rust. And so what they are saying is create a string. This is the string that we have. Ends with a semicolon. The every expression, every statement that is there in Rust ends with a semicolon. Now it says attach message to present, which is a function. So this is the name of your function, and then you are passing gift as a parameter here. Okay, and of course semicolons. And this is a print statement. In Rust, the way you print messages is using macros, or rather, println macro. So, what is a macro? Let's not get into it as of now. So, think of them as special functions that which end, or the name of that function ends in a exclamation mark. So, as we are saying, println print to print something, and then there's a new line character. It ends with exclamation mark, which means it's a macro. That's a standard that they follow. Defining a function in Rust is very similar to this. Um, in fact, maybe on this note, why don't we get into, instead, before just solving this, maybe just let's get into something. Okay. Let's try and start again from writing main and whatnot. Um, I already have Rust installed with me. And with Rust, you also get a Rust compiler, Rust C. Ignore the whatever you're saying in front of Rust C. Let's zoom in so you can see everything in detail. And I think it's large enough to for you to see. So Rust C is the compiler which using which you can build your Rust programs and run them. Let's start with the workspace and then playground. Okay. Now let's start off by creating a simple hello.rs. Okay, so every like any other programming language, Rust also comes with a main function which serves as the entry point, as I said earlier. So fn main is your entry point. This is your main function. This is serves as an entry point, as I said, and the program execution starts from there. The easiest way to get started with Rust is like any other programming language. Let's follow the trend. We go with printing hello world. Now, so we are in the Rust house directory, and the way to run this program will be Rust C hello.rs. We have compiled it. How do you run using Rust C? See, I'm a newbie myself. C run? Is it run? Or interesting. So that's our first challenge. First thing that we need to figure out. Okay, let's go back here. Uh, Run a Rust program is without cargo. Okay. So this is exactly what the stream is about. You and I both are beginners, and we will solve things, small things, and learn together. So I almost forgot how do you run a program without cargo. So how do you compile and run Rust programs? Okay, cargo new is definitely one. No, that's not what I'm looking for. How about Rust book? Let's do a hello world. And maybe, in case you're unable to see this, let's minimize this maybe. Okay. And zoom a little further. So this is something that we've already done. We have it in our main program. Oh, okay. Okay. Oh, I almost forgot. So, don't record. Okay. So when we compiled our program hello.rs, it created a file in the current directory as hello, which is an executable. So Rust C compiles your code and creates a binary. Now we can actually run this using hello. And we have just run our first program in Rust. Oh, I almost completely forgot that. Okay, it creates a binary. That's okay. I need to practice. All right. So this is how you run a program, write a program and build it, compile it, and run it using Rust. Next thing is instead of printing a hard-coded message, let's go ahead and maybe um, write a function that accepts certain parameters and accepts a string and greets someone, like basically a normal trend that we usually have in when we are learning any programming language. So let's say fn greet, and I would say name. So name is the parameter that the function expects, and this is going to be your type string. Now what I want to do is print ln, and I would like to greet the name, say hello, and then here. So if you're coming from a world of, I think, JavaScript, you must be familiar with string interpolation. This is right here is a classic example of string interpolation. Maybe I should move my cursor here. So this is string interpolation, where when the program executes, it will actually replace this placeholder with, with the value of the variable that you pass in. So let's pass in name. Now, so we have just written a function which is called greet, expects accepts a single variable or single parameter rather, name, which is of type string, and then we are just simply printing that name or saying hello to the person. We can also do an exclamation just to make it look good. And now instead of saying hard-coded hello world every time, what we want to do is we want to call greet and just pass in a string variable. Now the way you create strings in Rust is a little different, and string actually takes a lot more time. It's more of an if you want to deep dive into string, it will be a little complicated to understand as of now. So let's for the time being, let's go with the flow and say that you can create strings using this syntax. And let's say I want to say hello to Ferris. Who is Ferris? Ferris is the Rust mascot. And now we can again clear this. We use Rust C hello.rs, and we should maybe I should we have two binaries, one binary and the file itself. Let's remove the binary and let's recompile Rust C hello.rs, and we should now be able to run hello. Awesome. Now that we are at a stage that we know how to create a function, we know how to create a string, and how to call a function in Rust. Let's go back to the advent of spin, not advent of spin, advent of Rust. And just in case you're wondering what is advent of spin, it's actually another great advent that is happening. It comes from the world of WebAssembly. Yeah, if you want to check, you can definitely check it out. Okay, so we have we know how to run Rust on a local system. Now, okay, let's start with the we use. So there's a story which attaches or adds to the context of what's happening here. Feel free to read the story. yourself. Let's zoom in. So on the 1st of December, and the countdown just began. The elves are busy preparing for Christmas. So okay, I'm gonna skip this part. Santa, one of the elves shouted, "The code won't compile. We have hit a wall, and it's Rust fault." Okay, they're putting it on Rust, which usually is not the case. Okay, so if I run, no, we don't need to run. We know it's failing. We have hit a wall, and it's Rust fault. Santa asking, Rust fault or yours? It's the ownership rules. The other help started. I think we violated them. We are used to Python where variables just work. Look at this. Okay. We need to find a way to make the code compile without changing attach message to present function. Okay. So what's happening here is we have this variable which holds a string value. Okay. We have a function that expects a string, and what we're doing essentially is we're passing this into the string, into the function. Now, don't we cannot change this function, and what we need to do is we still this needs to compile. So there is a hint that we have is that we should clone it. Now, why need to clone it? It's a little, it's a bit of a later topic that I'd like to touch, but so um, think about it like this: strings in I think majority and a wide majority of the programming languages stay on heap. Rust does not allow you to have um, two pointers or two owners rather to point have an ownership on the same string. So what is asking you or what it forces you to do is it create a deep copy or rather a clone of the string, and then you can pass it to the function so that this function okay, let me try it this way. So you create a string, there is some message. Now this goes, there is a function like main has the ownership because the variable that is holding this message is stays within main. So we have your owner here. If we pass this message to another function and assign it to some variable like var, and we say, you can also take this message. Like, this won't work. Instead of imagine this, and right now, if we are if Rust allows for you to pass this string to this function, var will now also be pointing to a heap memory or an address on heap which is already being owned or referenced by the main function. Now think about this: when the function goes out of scope, the memory will be cleaned, which means the value that exists on heap will be dropped. And in such case, what owner is going to point to? Am I making any sense? If I am, the way Rust solves this problem by forcing us to create a clone of the string, which is the original one, and this one is the clone. Now, clone is it will be one owner, which will be the new function, and the message that resides on the heap. So that is why we are given a hint that you should be able to do a clone here. We run tests, should pass. Okay, so the tests have passed, and we should be able to submit. Okay, let's go back. We have completed the first one, getting ads. Let's go to the second one. Okay, let's see what's going on here. So we still have the same code address as last time, so there's nothing changed. But seems like there is another issue on Santa's end. So in this statement, Santa is not really happy with using clone. He's insisting on using references, and I think this is not the way I want to go about this. So I'd prefer not to use references and pointers straight away. I'd still prefer to have things very, very minimal. So I think I'm gonna have to stop using Advent of Rust as a reference here. Never mind. So we were here and we had our greet function which uses a string. Okay, so what do we want to build? Let's try and build something. Could we could we do something on the lines of we want to run let's say I want to have a program called Kelsey, and I'll pass in add, which is an operation that you can perform as a calculator. And let's say Kelsey by default has two operands to work on. It always, let's hard code those operands. 10 and it returns 20, which because it's operating on two hard coded operands, which will be 10 and 20. Oops. The at the rate key in my keyboard is not working properly. That's why you saw that. So imagine this, you have two operands in your binary, hard-coded 10 and 20, and you can perform certain operations on those. This could be your, let's say this is X, this is Y, and then you can also do LC minus. So this returns, um, okay, let me draft it better. I think we just got our first problem to solve. Let's remove everything. We have, let's create a file called kelsey.rs. This is going to be our very first program. Now, let's lay out the requirements very, very clearly. Uh, this is a way to add comments to your code in Rust. This is a line comment. This you can have like this. This is a line comment. And this is my editor doing the magic to do this. By the way, if you notice, I'm using Vim, NeoVim to be specific, and I'm not getting any auto completions. This is because my way of learning Rust or any programming language is that I should disable auto completions and should fight against the compiler so that I learn the language and I get more things to type so that I build a better understanding of the concepts and doing why I'm doing what I'm doing. That's the analogy. If you are more comfortable with VS Code or any other program, any other ID, feel free to use it. Otherwise, you can go with Notepad as well. I'm more comfortable with Vim. So this is a line comment. This I'll show you what a document comment looks like, and also show you how it works when we are building this. So this is line comment. Let's add a block comment as well. Rust also supports a block comments. This is a block comment. We can actually define all our requirement in here. So let's remove this and define what our application will look like. The Kelsey requirements. Okay, so what we want to build is a very simple calculator. Assumption. Okay. Let's say our calculator only operates on two operands. Operands are hard coded into x, which is going to be, say, 20, and y, which is going to be at 10. All right. Now, what are the operations that we're going to support? We want to support add, minus, or you can call it difference or subtract, whatever makes sense. Product. I don't know what else to call it. Multiplication, or you can call it multiply. It makes sense. Divide, and what else? Do modulo. Do we also want to support modulo? But okay, let's start here. Let's stop here. So let's build this. What I want to do is let's also add a usage. So how do you want to use it? How do you use the binary is something like this. I'd prefer to use it something like Kelsey add, and what it does, the it returns returns the sum of x and y. And in the same way, I could also do minus, which returns the difference between x and y. Basically, it will return x minus y. Returns the difference. Minus y. So you get the idea. Let's start building this. Okay, so there will be a function main, obviously. Let's write something so that we know it's working. Hello, Kelsey. Just so we know that our program is actually compiling at different stages, I'll keep compiling it on different stages. Let's call it kelsey.rs. Okay, we should have Kelsey. Hello, Kelsey. Okay, so our program compiles at least at this point. Now, what I want to do is I would prefer to have and um, let x be equal to 20 and let y be equal to 10. Okay. And now what I would prefer to do is call a function with something like Kelsey, which accepts which expects two operators, operands x and y, and it does perform something. Let's call it result. Okay, there's a before we actually get in there, just realize that this is going to be this will pass as an argument. So we first need to understand that how do we get the argument. Okay, so if I want to, so what you want to do is do something lc add, and in our program we should be able to receive add. So let's first check how do we pass the command line arguments. As far as I know, based so since I have worked with programming languages like Go, and also worked with Java and C Sharp, I know that when you execute a binary or when you execute a program, what happens is you usually receive an array. So it's usually in this form. So at the zeroth index, you have Kelsey, and then going forward, you will have any other argument that you pass to your binary. So we have Kelsey, and then we will have add at the first index. The question is, how does Rust manage the same thing? How can we get the arguments from Rust? So let's go back here. Let's close this, and I think this is the perfect time to introduce you to Rust standard documentation. If you type in the browser std.rs, this will take you to the Rust standard library documentation. And this is a great place to search for. Uh, it would either be, it should be something to do with args. So this is my guess, and should prefer to go with args. Okay. I think I'm zoomed in a little too much. So okay, I can minimize it. Nice. So it says an iterator over the arguments of a process in vargs. This is a struct, this is a function, returns the arguments that this program was, returns the arguments that this, okay. I think this is what we need. This program was started with normally passed via the command line. Okay. So we know that we need this, but how do we execute this? Like, how do we use this function in Rust? Here's an example. So we do use standard env and then env args. Okay, this looks like there is a sort of namespace. The right way to call it in terms of Rust is modules. So standard is your I think it's the core where you have all the standard modules or standard library that is present, and then we have env module inside standard, and then the env has this function called args. So let's use this, and maybe we see what we are receiving. So let's use standard and env. Uh, let, let's let's comment them out now. And what I would like to do is print ln, let's get args be equal to env args. And what does it return exactly? we can actually print the arguments. Okay. Oh, wait. It's doing it in a loop, which means it's returning a sort of list or vector. I think we have vectors in Rust. So let's do the exact same thing. Let's arg. I'm not putting too much brain into what's happening here. Okay. Uh, so the way loop, I'm assuming, I do not know whether it's an iterator or a list. So I'm going with the assumption that it's returning a list of arguments. And the way we loop in Rust over any collection is using a for loop. There are different ways you can loop on different. I think you have while loop, you have for, and you can do a lot of things with them. But for now, without putting too much brain into this, let's loop over args. And what we would like to do is print. We talked about the interpolation thing already, and we should be able to call it. So rust c calc.rs, and if I run calc.rs add, I'm hoping to see uh, calc and in the next line add. Okay, so yeah. So this gives us the list of operands that we pass in. And what if I pass in more? Okay, so we get all the list. All right. Now, this is good. What I would like to do is get the very. I would prefer to skip the args part. So we remember we were getting dot kelsey and then we get add. So this is at index 0, and then we have at index 1 add. I prefer, I just want to get add. Can I do that? And how do I do that? That's the that's the better question. Okay, so I want to do is be able to args 1. Okay, no. So I have this setup using in my system in my Vim that if there be any errors, I'll get a warning or something. So if I were to do, oh, interesting. I just learned something new about my setup in. So if it's not considering it as a, it's not parsing it or it's not doing a check on the fly. Interesting. So if we run our program now, will we get add printed? Uh, nope, we are not getting. Oh, I never compiled. Sorry. All right. So we have an issue. It says cannot index into a value of type args. Okay. I didn't know that it's not that it's not actually a list. Now we have to look further. Hmm. Okay. Okay. Something I totally ignored. So pub function args returns an args. Okay. And args implements an iterator. That is why we were able to loop through or iterate through the arguments. So The next question is how do we get to the first element that is of our interest? One way to do this is we we intentionally loop it, and as soon as we have the first argument, we just use that and just break out of the loop. That would be the naive way of doing this. We can actually start there. Yeah, it won't hurt, but it will be it's an iterator pattern. We I don't think if you will able to index over args, I don't think so because it's not allowing to index there. So it definitely won't allow us to index if using. So okay, so what I had in mind is was to do something like I equals to 0, and we can do that using a while loop, but I don't think it makes much sense. So let's see if there is a way to skip. So if I zoom out a little bit, on the left side, you see what struct this standard or env has and what functions they provide. So we can loop over these functions and maybe we'd find something. So we know we have args. Okay, what do we have in args? So right now I'm at struct args. Okay, so it implements an iterator. Is there a way to skip something? Interesting. So there is a way that skips over. So there is a function called skip. There's a struct called script skip. So an iterator implements a skip. No, wait, I'm getting issues. Any chance? Okay, we didn't get much help there. Or maybe I'm not looking the right way. So this struct implements certain traits. The, you can, as of now, you can think about traits as simply interfaces or functionalities or kind of behaviors that they expose. So we know that this implements the trait iterator. Okay, skip while. If there is a skip while, creates an iterator that skips an element based on a predicate. Sounds a lot. Creates an iterator that skips the first n elements. Okay, this makes sense. Creates an iterator that skips the first n elements. Skip n skips elements until n elements are skipped, or the end of iteration is reached. Okay, whichever happens first. So here's a quick view. Okay, so we can do something similar. So we are also receiving a collection. Then we have iterate, we iterate over it, or we do an iteration, and we skip. Okay. We could also have done something different. So Okay, so this returns an iterator. I know that this is what I'm expecting. At zeroth index, I have the, the add. This is an iterator. So can I not do, okay, let's give, let odds. I can, so in Rust, we can redefine the same variable. And this variable will be redefined at this, when I'm saying this variable will be redefined at this line and reinitialized. So I can say args will be args dot next or args dot skip one. So we have a new iterator. Maybe we can actually change this. Skip one and let operation that we want to, or op rather, the way what we want to perform is in args dot next. And let me just print. Ooh, can't do it. Okay. So we're getting an option of string. So okay. So args.next returns an option. What is an option? It's returning an option of string. Option is actually an enum, and I didn't really want to get into this, but here we are. So option takes, it's an enum. As of now, just think about it as whether you there is an option whether you will have a value, whether you can have a value or you cannot have a value. So meaning either the value is present or the value is not present. It's as simple as that. But it gets a little it's very handy when it comes to building real programs with Rust. But for now, what you can actually do to get the value out of an option is to unwrap it. Unwrap means we don't really care whether the value is none or whether the value is none or it's present. We just want to say, just unwrap it, whatever it is. So imagine this more or less like, imagine this to be a similar situation like on Christmas, you get a gift. You just want to unwrap it, you want to open it, irrespective of whether there's actually a toy there or not. You just want to open it so that the suspense is revealed. It's over. So as of now, we should be able to get the operation. Press C, compile. Not able to compile it still. Did I not save it? Hmm. Another problem. Okay, so I'll um, okay, so we are again in the same director as stars. It's just that I wanted to have a better view on the error that we're getting so that we can talk about this, not cargo. Um, Plus C, can see.rs. Okay. So it says cannot borrow as mutable, cannot borrow args as mutable as it is not declared as mutable. What does that mean? Seems a mouthful. So by default, any variable that you define in Rust is immutable, meaning once a value is assigned to it, it cannot be changed. You remember at one line we were doing let args equals this, and then on the next line I was doing let args equals to this. That is a redeclaration and initialization of the variable at the same line. That is still fine. But since we have args defined, uh, this will initialize something. And what I'm doing here is chaining of operations. So it's very much similar to saying this let args. Um, what this essentially means is I'm doing something like this args equals args dot skip. This is what it's doing. If I'm doing this is very much equivalent of doing this let args be equal to env args dot skip. This is called method chaining or function chaining, whatever you call it. So what we're doing essentially is chaining two functions and get assigned the value. So Rust is what the, so let's recompile it and probably then you'll be able to understand what I'm trying to say. So we declared args, we assigned a value to it, and what we're trying to do is we reassign args with a skip, but it's saying mismatch types, which is fine. Oh, my bad. Because now I've skipped, which is again, it's going to be a skip args. Wow. Welcome to the world of Rust. See, it's better to learn together. I have messed things up in such a small program. So, but at least you get an idea about what immutability means. Simple way to get around it is this. Okay, you're able to build now. Kelsey and we get Kelsey. Oh, I didn't skip. Okay, we get add. All right. So what we're doing here is just declaring args as mutable. That whether or not you are so okay, let me try and re-explain this because I didn't do it very good at the first hand. This portion here returns args of bad args as in the struct args. This portion here returns skip args as you saw in the error message above. So this portion env args returns a struct args, but this whole thing returns skip args, which are two different types. And we were trying to assign a variable args, which is of type this args, a value of kind skip args, which is a problem. And that is why it's saying if you change it to be a mutable value, we will still be able to replace the existing value with a new one. It sounds like a mouthful, but if you take a pause and think about it, it actually makes sense. Maybe. So now we have an operation, and this is op. So what we can do is we can do a little if op equals to add, Um, and you remember we know that the way to create strings is string from. It's at least one of the ways to do it is this. And now, what I want to say is maybe executing the operation can also get rid of this. Executing and okay, that's what we expected. So what we essentially did, we got the operation that we want to perform, and then we ultimately have this being checked so that we can perform the execution. And more so, we can therefore have now we definitely can have more. Maybe I should replicate. So if operation is this, the other one we had was I think minus. This can be multiply. So we have these many. Okay, so we have added multiple conditions. Performing the operation is fairly easy, and we can at the end just print out the result. That should be fine, and I'm sure you can do that. Um, but for now, let's quickly run. Let's see. Let's recompile it, and if we do say divide, yep, it's executing the divide. And since we are doing an operation with a particular check, like only after a check, we don't really need to do if else. We don't need to do that. But the way you do it in Rust is you have to the the else block need to follow the last curly brace, and it has to be in line. You cannot do something like this. It has to be this format. So you cannot do in a new line of else. Okay, so what we want to do is we have two operands. Let's uncomment them out, and maybe let's also declare result. Let res be the initialize it to 0 at the beginning, and I prefer to okay, let's keep it this way. I was thinking that maybe I should move these two lines to the top, but I think it's fine. Now, instead of printing every operation, I would maybe let's actually perform the operation. So I would say response is equal to x plus y. Response is equal to x minus y. Response equals to x multiplied by y. And for the division, let's do it. Response equals x divided by y. And at the end of the program, the end of main, I prefer to print the result. And I would like to say the the op of x comma y equals something of this sort is equals to what is what it resulted into. And if I'm following correctly, it should fail to compile. And if you have guessed it so far, I mean, if you've been following so far, you know exactly, or you should know why it's failing. Let's let it fail, and then we will see why it failed. Okay, so it failed. Cannot assign twice to immutable variable. Cannot assign twice to immutable variable. And the reason being, the first assignment that happened here, so in the very beginning of when we declared response, we said that it needs to be assigned to 0. Okay. And this is immutable by default, which means, excuse me. So it says, if you look at the help, consider making this binding mutable, declare response as mutable, which means, and then we will be able to assign it multiple times and as many times as we want. So let's go back and declare it as mutable. And now we should be able to compile it. Yes. So let's run the program. Divide of x comma y is 2. Not such a fancy output, neither a fancy function, but it works. Okay. So I think this is the time where I would like to stop. Next, the next stream, I hope we can start from here only. And there are a few things that, what if y is set to 0? I mean, this is all hard coded as of now. We are not expecting x and y. Maybe try to extend this application and do something of the sort. Divide, say 50 and 4. So try update this code and be able to pass more arguments to it and be able to run them. This will be interesting because you will need to accept two more arguments. You will need to change this, and at the same time, I think that will be a good idea. In such case, it would be a good idea to loop over the arguments, and when you do a next, you get your two operands. But question is, what if the user provides three? So when you're doing an add, uh, a user can definitely provide three arguments, right? You want to add x, y, and z, 10, 20, 30, and ultimately you should have 68 printed out. So how do you tackle such situation? Um, that would be an extreme. It would be interesting to extend this further, build on top of this, and maybe, I mean, just maybe, if time permits, we will actually push things to GitHub. I think it would be a good starting point for anyone to start with what we're doing here. Awesome. Thank you for joining. I'll stop here and say hello whenever you can. I'll be around on Slack. I do exist on Kubernetes Slack. I do exist on CNCF as well. You can connect with me on LinkedIn and Twitter. Thank you. Bye bye.